Hey, how's it going? This is Keith Morgan for TechTyro.com, and today we're going to be taking a look at how to fracture an object in Blender. So, we're going to start with the vase Corwin made in our previous tutorial, and to start we're just going to give it a little more geometry so we can use it a little bit better to our advantage. So I'm going to go to the Modifier tab, and I'm going to add a Subdivision surface modifier, and we're just going to give it a view and render of 1, and then we're going to apply it. And now we're going to go to the cell fracture option here, and if you don't have that, you can enable it by going to your user preferences under the add-ons and under the object category, enable cell fracture, and while we're at it, we're also going to make sure our fracture tools are enabled. And once we have that, we'll just click on cell fracture, and now you see we have some options here. Now the one we're going to utilize uses the grease pencil, but we haven't done anything with the grease pencil yet, so we're just going to backtrack one step. And if you were going to execute this right now, it would break up the vase, but we want it to have a little more customization and controllability and a little bit more randomness than what the default settings would give us. So we're just going to click off for now. And over here, we're just going to go over here and choose a new grease pencil and make sure our drawing settings are for surface. And I'm just going to go to our front view. And so now we're going to make it look like as if the vase here is going to be shot with a bullet or an arrow. So I'm just going to start by drawing radial, a bullseye of sorts, radiating out from a single point. So to use the grease pencil, you keep D down, and then you can just keep drawing with it. And we're just going to draw a few times, a few rings, and once we get a few we like, we can just start doing these radial lines coming out, much like cracks. And these will just help create more shards and add a little more randomness to our fracture. Then we'll just orbit around and go to the back view, which you can get to by going Control and 1 on your number pad. And once again, we'll just hold D and start drawing some more. And just keep doing it until you get something you like. You never really know what it's going to look like till you fracture it, but that's part of the fun. So we'll just keep going. Get a couple on the bottom there. You want that to break apart. I think you don't have to go nuts, but if you want a lot, go do a lot. And we'll get a couple on the inside here and a couple on the rim. And there we are. So now that we have our grease pencils set up, we're going to go to the cell fracture tools again. And we'll uncheck own particles and we'll check grease pencil. And then we will just, all these other settings look good for right now. And we'll hit OK. And it'll go about shattering the object randomly using our grease pencil data. And then it will give us our object fractured. So you might notice now that nothing looks like it really happened, but it did. So I'm just going to go over here and click the little eyeball on our grease pencil to hide it. And you'll notice down here in our layers tab that we have a new layer, and that is where all our fracture objects ended up. And you see it worked quite well. Now, if this didn't work out for you, I've set up another example. If you got a result much like this, where your vase is a negative space inside of a bunch of fractured objects, what happened there was your normals on your vase, your original vase, were flipped inside out. And so that really just wreaks havoc with the fracturing simulation. So here we have another vase, and all the normals are flipped the wrong way. So if you want to see which way your normals are facing, you go into edit mode, and then you scroll down over here, and you see this option that says normals. You can hit the face, and you can see that we don't really have any things showing up. So what you can do with everything selected is just go over here and choose flip direction on your normals, and you'll see that all of those line segments are now pointing directly out of each face, which is what we want. So if you were to fracture this again, you would get the proper first result we had and not the second messy box like that. So moving on, we have our properly fractured vase here, and I'm just going to go ahead and hit 1 to go into our front view. I'm going to hit A to select everything on the layer, and then I will shift select a single piece to make that one the active object. And we're going to switch, if you're not already in Blender Game, switch to Blender Game now, up here at the top. And we're going to go over to our physics panel, and You may have noticed that when you switch from Blender Render or Blender Cycles to the Blender Game Engine, you get a bunch of different physics properties. These are the game engine physics properties, and we will be utilizing them to run our physics simulation to actually shatter our broken pieces now. So with our one piece selected here, we're just going to go ahead and make sure that it is set to a rigid body, and we're going to make sure its collision bounds are convex hull. Now, if you go look through these different selections, these are just different ways the simulation can interpret the collision bounds of each object. So they start out really, really general, and they get more and more specific. A triangle mesh is it pretty much sticks right to the exact geometry of the object, but it is a heck of a lot more intensive to calculate. So we're just going to stick with a convex hull, which works perfectly right now. And the margin right here sets the error limit for the simulation. So you want a very small amount for an amount of stabilization in your simulation. Otherwise, just random stuff could happen and you don't want that. So we'll just set it to 0.001, and that should be enough. And then we will go and we will just drag up our timeline here, and we're going to change it from a timeline down here to a logic editor. And this is how we will set up our game engine properties and how the objects will act when we start running our game. So let's just take one here, the one we were using, the face cell 42, and we'll add an always sensor, and we'll skip the controller for now, and we'll add an actuator of edit object. And instead of add object for the edit object property, we'll change it to dynamics. And for the dynamic operation, we will suspend the dynamics. So if we connect the two nodes between the always and the edit object, what this basically does is it says always suspend the dynamics of these particles, or rather these shards. So if we go and add another sensor, we'll say a collision, and we go and add another actuator of edit object again, change it from add object to dynamics, and then restore dynamics. So if we connect those two nodes, and then it goes and adds an AND controller by default, what this says is that always keep the particles suspended until they are collided with, in which case restore their dynamics. So with that set up, we can hit A and make sure that that one we had edited is still the active object, which you can tell by this yellow bounding box. And I'll just go into wireframe so you can see that. And so what you want to do now is go Object, Game, copy logic bricks, and what that does is that all of these logic bricks we set up down here for that one object will now be copied to all these other objects we have selected. And likewise, we want to go Object, Game, copy physics properties, and that'll just make sure we don't have to set any of these settings individually for these. It'll just copy all those over from that one we already set. So with that set up, we can now, I'll change this back to a timeline, and I'm just going to save. So now that we got that, we are going to make sure our 3D cursor is on the ground, and we're going to add a plane, and we're just going to scale it up so we have enough room for our pieces to fly off of when we start running our simulation. We're just going to move it so that it's just slightly below our face so it has enough room to detect the collision bounds. We're going to tab into edit mode, and we're going to extrude it down on the z-axis just to give it a little more dimension so it has more information to detect its own collision bounds, and so pieces don't just go falling through it. And we're going to make it a static object with a collision bound of a box with a margin of 0.001. And a box should be perfect for this as it is a box itself. So now what we can do, if we hit P, which starts the game engine, you'll see, oh, well, nothing happens. But that's because we have our suspend dynamics controller or actuator on. But we need something to collide with this object, and that will start the physics. So we can either add a new, let's say, a UV sphere, and we'll just give it 16 segments and 8 rings, and we'll move it up on the z-axis here, and we can turn it to a rigid body and give it a collision bound of a sphere. That looks pretty good. We'll just give the margin of 0.001 again, and then this time And I'll just add a point lamp so we can see what's going on here. If we hit P, the ball will drop and it'll shatter the vase. And that looks pretty good. So, but the only issue is when we hit P to play our physics, or play our game rather, it doesn't record any of it. It just reruns the simulation every single time. So, you know, depending on how it interprets it, you could get different results every single time. But generally, because it's using the same physics every time, all of the results will generally be quite similar, so don't really worry yourself on that. But what you can do is you can also record the physics, and that will convert it to keyframe animation on each of these pieces, which we can then use later. So to do that, we will go Game, and then Record Animation. And then if we hit P, it'll start playing the game and running our simulation here. But you have to have your hand ready on the escape button because it will record, it'll just keep recording keyframes, and that can really bog down your system if you record a lot of keyframes, which it does. So, you know, you only want to record as many as you need, and then just hit escape when you have as many as you think you need. Otherwise, you'll just keep getting all these keyframes, and it'll just be mess. So, without further ado, let us hit P. And then we'll just wait for that to fall and hit escape. And now, if we select one of these shards, we can see we have all these keyframes. And just a reminder, when you start recording the animation, depending on what frame you're starting at is what frame it'll start recording the animation at. So if you see, I had my timeline marker at 7 frames in, so that's when it started recording the animation. If we wanted to go back, and if I hit P again and reran it with our timeline, our timeline bar at 0, you'll see that it re-recorded that physics with new keyframes starting at 0 frames. So that's just how you can fix that if you want. So, you know, it looks good when we're just scrubbing through it, but what actually goes on here is it's playing a lot slower. Like if we were to hit play, it would play a lot slower than we really think it's going to be. So if I just hit play, you know, it's going about 20% of what we actually thought the speed would look natural at. So to fix that, and we really don't need this sphere anymore. We could replace with any object. Like you could incorporate it into a scene where someone's karate chopping the damn face, and you know that would look pretty sweet. But yeah, don't even need stunt doubles. Just make a blender vase and shatter the pieces out of it, and go nuts. But yeah, you can delete the sphere after you're done with it. You can delete the ground plane. You know, have it end up on a floor. Who knows? And that just looks good too. But anyways, so we'll select everything. And then we'll go over here, and instead of timeline, we will choose dope sheet. And what dope sheet is just a record of all the keyframes, just shown on a table of sorts. But what we can do to speed up this animation is to scale it on the x-axis, which you can just hit by hitting X. And if you look down here in the bottom left here, when I start scaling, you can see that the scale factor is shown, and I guess it defaults to X, so you don't really need to type X, but we can just hit in type 0.2, and that makes it 20% of the original length, which is about probably what we want. And then we'll just hit G and move them over on the X, just so that it lines up with 0. So then when we hit play again, and we go back to our timeline, it plays at a speed that seems realistic to our eyes. So, I would say that that is a very well smashed vase, and we can give that, you know, just give that a render if you want. But that's where I'm going to leave it for now. So I hope you really enjoyed learning how to fracture an object with custom grease penciling, fracture objects, setting up your physics nodes, and all that good stuff. Really look forward to seeing what you guys do with it. And until next time, this is Keith Morgan for Tech Tyro, signing off.